Question number 5 looks at radioactive nuclei, and the first thing it asks us for the type of radiation that is the most penetrating, so which can go through the most material, and that is gamma radiation. The most ionizing is alpha, and it has the biggest mass, biggest charge. It's very good at removing electrons from atoms. Which type of radiation has the longest range in air? So you're looking at gamma, which is in the order of kilometers. Next, when radioactive isotopes in the Earth's crust decay, they release energy. This causes the heating of rocks in the crust. So you can see an example of one of the decays that happened. So this is giving off a helium nucleus, which is alpha decay, so 2 protons and 2 neutrons. Here we have a table. We need to complete it to figure out how many protons it's got. So if it's uranium-238, well, we can look up here. It tells us that the atomic number is 92. If the atomic number is 92, then the number of protons we have must be 92 as well. Thorium, a number of neutrons, so it's 234 and 90. So 90 is the number of protons, 234 is the number of protons plus neutrons. So if we were to do 234 minus 90, that would give us our answer. So again, always use your calculator. 234 minus 90, 144. Uh, 5.5. Geothermal power stations pump water through heated rocks. The temperature of the water increases from 20 degrees to its boiling point of 100 degrees. So we're going to need to do a change in temperature for this. So I'm going to annotate that 100 minus 80, oops, silly me, 100 minus 20 is 80 degrees Celsius, and that's our change in temperature. Next we get given a mass, 150 kilograms, and a specific heat capacity. So the energy, or the change in thermal energy, delta for change in energy, is equal to mass times the specific heat capacity, given the symbol C, times by the change in temperature. So sometimes you'll see that given the symbol theta, but I've chosen to use capital T for temperature here. M is 150, that's the 150 kilograms. The specific heat capacity was 4,200 joules per kilogram degrees C, and that's multiplied by that change in temperature we calculated earlier, which was 80. So a lot of people would want just to put either the 20 or the 100 in. That's going to limit the number of marks you get. You're going to lose marks for doing that. So calculator once more, 150 times 4,200 times 80 is a large number. So 504, 1, 2, 3, 4, 5, and I'm going to convert that to something more useful. 5.04 times 10 to the 1, 2, 3, 4, 5, 6, 7 times 10 to the 7 joules.